How to study the chemical reactions of ammonia. Ammonia is among the most produced chemicals in the world. The compound is readily synthesized and serves a variety of uses. You can study ammonia and its reactions by reading about the compound, or experimenting with it in the lab, depending your background in chemistry and access to equipment. You will find that ammonia can react in many ways, and even the synthesis of the compound can require a good deal of thought. Method 1: Studying specific reactions and uses of ammonia. 1. Research the use of ammonia in farming. Nitrogen is essential to the growth of plants. You can mix ammonia in the soil to be metabolized by bacteria present in the soil. The resulting compounds are nitrite, NO2, and nitrate, NO3. These compounds can be readily used by the plants for growth. To learn more about the amount of ammonia in your soil, extract the nitrogen compounds from the soil in a lab test. Put your sample in an oven, 850 degrees Celsius, and add plenty of oxygen. The oxygen at this temperature, nitrogen compounds will combust, resulting in gaseous nitrogen oxides, NOx. The gases can be collected for analysis, and the amount of nitrogen in your soil sample can be determined by how many NOx gases are present. 2. Familiarize yourself with named reactions of ammonia. Ammonia has many uses, and some of the more specific reactions are named. The synthesis of nitric acid is referred to as the Ostwald process, and involves combining ammonia with excess oxygen under conditions that yield nitrogen dioxide. The NO2 is then bubbled through water, which absorbs the gas and converts it to nitric acid. The Solvay process bubbles carbon dioxide through a solution of salt water and ammonia to make sodium carbonate, soda ash. The list goes on, and these specific reactions got their own names because they met a certain need using the ammonia compound. 3. Consider how ammonia affects fermentation. During the fermentation of wine, ammonia exists in the form of the ammonium ion, NH4+. This compound is utilized by yeast to produce amino acids and other cellular materials. Without the nitrogen, the yeast would not be able to reproduce and convert the sugar in the grapes to ethanol. Method 2: Understanding the general reactivity of ammonia. 1. Know how ammonia acts in water. In water, ammonia acts as a proton acceptor, or Lewis base. This means that it readily takes a hydrogen molecule from the water to form NH3+. This forms OH molecules, and raises the pH of the solution. The high solubility of ammonia can be shown experimentally by turning a tube of gaseous ammonia upside down in water. As the ammonia dissolves into the water level will rise in the tube. 2. Understand the stability of the ammonia molecule. Ammonia is stable under most conditions. It can tolerate being exposed to light or heat. Though ammonia is caustic, it will not corrode mild or stainless steel or glass, but it will damage galvanized steel, copper, zinc, and some other metals. Ammonia can form explosive compounds with some metals. Silver and mercury should not be exposed to ammonia for this reason. 3. Consider ammonia under basic or acidic conditions. Ammonia readily reacts with acids to form salts. This includes strong acids, weak acids, and Lewis acids, proton donors. Because of its ability to react with acids, ammonia does not allow strongly acidic solutions. It does, however, dissolve some bases to create strongly basic solutions. Ammonium sulfate can be readily made in a lab. Mix sulfuric acid and ammonia together, boil gently, and pour into an evaporating dish. As the water evaporates, ammonium sulfate crystals will precipitate onto the evaporating dish. Sulfuric acid is highly corrosive. Wear goggles, gloves, and protective clothing. Do not inhale sulfuric acid or ammonia fumes. 4. Study the reactions of ammonia with halogens. Ammonia reacts to halogens very violently. This results in a type of reaction called ammonolysis. In these reactions, at least one of the hydrogen atoms is replaced by another type of atom. Though ammonolysis is very common between ammonia and halogens, it isn't limited to halogens. Other compounds can replace a hydrogen as well. You can observe a safe version of this by soaking a cotton wad in ammonia and a second cotton wad in hydrogen chloride. Put the wads in opposite ends of a glass tube, and for a ring of white powder to appear. This powder is ammonium chloride. 5. Remember redox reactions. Oxidation, reduction, or redox reactions also occur with ammonia. Most notably, ammonia will burn in the presence of oxygen gas to produce H2O and N2, nitrogen gas. Ammonia can also be used to reduce the oxidation of hot metals, such as cupric oxide, to a non, or less, oxidized state. To demonstrate ammonia's potential for redox reactions, you can ignite ammonium dichromate, 6, and watch the reaction. Be careful to do this in a fume hood, on a heat-proof surface. Method 3. Understanding the synthesis of ammonia. 1. Know that nitrogen and hydrogen are the necessary reactants. Consider the chemical equation of ammonia, NH3. You can tell from this equation that one nitrogen molecule must bond to 3 hydrogen molecules to form the compound. This process is started by introducing a ratio of 3 hydrogen to 1 nitrogen into a chemical reactor that contains a catalyst. 2. Understand that a catalyst is needed to speed the reaction. You should first know that the catalyst does not directly react with the reactants. Think of it as a way to speed up the reaction that would happen anyway. In the formation of ammonia, the catalyst is an iron compound that contains potassium hydroxide. You should note that using the catalyst will only speed up the rate of the reaction, and will not increase the overall percentage of ammonia that is formed in the end. 3. Consider the effects of heat on the synthesis reaction. Understand that temperature is a double-edged sword in ammonia production. You can lower temperatures to get the best conversion of N and H into NH3. The downside is that by lowering temperatures, you also slow down the reaction. Most ammonia manufacturers use a temperature between 400–450 degrees Celsius. Le Chatelier's principle governs how heat will affect the shift of N and H to NH3. 4. Contemplate how pressure will change the reaction. You can also alter the conversion of N and H to NH3 with changes in pressure. If you use a higher pressure, you will bring the molecules closer together and promote the reaction that forms ammonia. Creating extremely high pressures is expensive. You have to buy the equipment to generate the pressure and contain it, so a middle ground is often sought to produce ammonia in a cost-effective way. Most manufacturers use a moderately high pressure of around 200 atmospheres. 5. Study the extraction technique for ammonia produced. Once you have successfully produced ammonia, it will be amongst other gases, specifically nitrogen gas and hydrogen gas, at a high temperature and pressure. Luckily, you can liquefy ammonia more readily than nitrogen or hydrogen. You should cool the gases to around 30 degrees Fahrenheit to allow the ammonia to precipitate out as a liquid. The remaining gases are recycled through the reaction chamber to make more ammonia. Tips. There are a countless number of uses for ammonia, including alternative energy, cleaning, use in refrigeration, syntheses of many compounds, etc. Warnings. Ammonia is highly toxic. Obtain a materials safety data sheet for any chemicals you are using, and follow all safety precautions.